So let's take a look at number 9. Number 9 is different from all of the types we did yesterday. What's the difference? It's missing a term, but some of the ones yesterday were missing a term. It's missing an x term. So usually when there were two terms, we could pull something out. But the x and the 121 don't share anything, so we can't factor anything out. Does anybody remember how to factor this type? X and x, they have to be different because it's negative 121, so it's minus and plus. They have to multiply to 121 and equal 0. Good. That missing number is a 0x. So are there factors of 121 that will turn into a 0? 11 and 11. And that's a really good way to say that, whoever said it, you. So the answers, and if you're lazy like me, you can just write plus or minus 11. That represents both the x, the positive and the negative version. So what about number 10? Let's try to factor 10. X and x, and they're the same, so it's either plus, plus, or minus, minus, and what do they need to add to be? 0. Well, if it's plus, plus, how do you get a 0? You can't. If it's minus, minus, how do you get a 0? You can't. So this one's not possible. Does that mean that it doesn't have roots? It has roots. We just don't know what they are, and in this case, they're imaginary. But you might not know that by just looking at it. I know from looking at it. But it has two imaginary roots. Okay. 11's tricky. 11 is just like number 9. But this time, instead of being x and x, it's going to be something that multiplies to be 16x squared. But we know it has to create a 0. So whatever numbers we put in there, they have to be the same on both sides. So can I split that x squared term into two numbers that are the same? 4 and 4. What do I know about the signs? Plus and minus. 3 and 3. Okay, that wasn't so bad, but what are the answers now? Set them equal to 0 and then solve. Usually, like on number 9, all you have to do is change the signs. But in this case, changing the signs would give you 3 and negative 3, and that's not the whole story. So we're going to subtract 3, minus 3, and divide by 4. So x is negative 3/4 and positive 3/4. And if you're lazy, you can write plus or minus 3/4. Does anybody remember the type of quadratic that is? Number 9 and number 11? Perfect square? No. Difference of squares. A perfect square would be like x plus 3 squared, which is x squared plus 6x plus 9. That's a perfect square trinomial. And we'll deal with those a little bit later. But the one that we're looking at in number 9 and number 11 is called a difference of squares, where the first one is a perfect square and the last one is a perfect square, and there's a subtraction. And we can see why there needs to be a subtraction. If you look at number 10, on number 10 we have two perfect squares, x squared and 4, but because it's a plus, we cannot get a 0. There's no way to use two positive numbers to get a 0. Okay. What are we going to do for number 12? Divide everything by 4, and then it works just fine. But then, look at number 13. So it would be x squared minus x minus 20. Yeah, and then you guys know how to do that one. But 13 is a little bit different. 6 doesn't go in, but something does. So you could turn this into 3x squared minus 16x minus 12. Well, 2. I took a 2 out, but that's as far as you can go. So this brings up another type of quadratic, and you may or may not know how to solve this. So let me see what I did with the paper that I was going to use. Okay, so work these problems on the back. We'll work them together. Whenever you have a number in front of the x squared that does not factor, it works a little bit different. So if you have a quadratic that has a leading coefficient, the first number is called the leading coefficient. If that doesn't factor out, then you have to factor it differently. So let's consider x squared minus 13x minus 5. Can I factor anything out of that? No, so work this one on the back somewhere. It's not one of your problems. And these are quite a bit harder. But if you can remember the steps, you can always get the answer. And the nice thing is, you can always tell if you've done the problem right. If you've done it wrong, it's obvious. But sometimes finding the right answer is a little bit hard. So normally, we factor the 5. And we look for the factors of 5 that add to be 13. But in this case, we also have a 6. So that 6 is going to combine with the 5 somehow and make a 15. So what we're going to do is multiply the beginning and ending terms, and we get 30x squared. Now, that 30x squared is what we're going to use to create that 13x. So we go through the factors of 30, and I'll write them down. What do I know about the signs, first of all? They're different because this is a negative. So the first terms that come from the 6x squared are always positive. Yeah, so if this is negative and this is negative, then the bigger one's going to be negative. Yeah, good memory. So 1 and 30, will that give me a 13? No. 2 and 15, there we go. I heard 3 and 10. Would 3 and 10 give me a 13? It would, but the signs are supposed to be different. So we're going to split this into 2x and negative 15x. And that's the hard part, is remembering what to do with that 30x squared. Once you find the numbers, you split them into 2x and negative 15x, and I'm going to bring down everything else. So that would be plus, and I'm going to bring down my negative 5. Now, have I changed the original quadratic? Kind of. Have I changed its value? No, I just changed how it looked. I took that middle term and I split it. Now, we're going to factor by grouping. If I look at the first two terms, does anything factor out of those first two terms? 2x. What would be left? 3x plus 1. Not 0, 1. Because if you divide out everything, you still have a 1. There's no way to divide and get a 0, unless you like doing math with infinity, and we're not there yet. Okay? Now, can I pull anything out of the second group? I can pull out a negative 5. And the negatives, that's going to give you some problems on certain problems. Does that make sense? So I'm going to pull out a negative 5, just because they both have a minus. If I pull out a negative 5, what do I have left? 3x plus 1. And I automatically know I did it correct, because 3x plus 1 matches 3x plus 1. Now, if I would have pulled out just a 5, would this parenthesis have matched this one? Right, the second group would have been negatives, and I would have said, wait a minute, they need to be the same. So if the numbers are correct but the signs are different, just bring out a negative. Okay? All right, so now we're going to factor it out again. So, and there's a hard way to think about this, and there's an easy way to think about this. We'll look at both. If I look at the whole thing, does the first term match anything in the second term? They both have a 3x plus 1, so I can pull out a 3x plus 1. If I pull out a 3x plus 1, what's left? Good. Now, you don't actually have to think of it that way. You can automatically say, this is an answer, and this is an answer. And that will be the same for every single possible problem. So now I just set them equal to 0. What do I get when I solve for the first set? Well, at first I subtract 1, get negative 1, and then divide by 3, so negative 1/3 is one of them. Add 5 over here, and divide by 2, so I get 5/2. And those are my two answers. How about 3 more times? Yes. Right. So when solving for order of operations, we look at the x. What's the first thing that happens to x? The 3. And then the 1. So if we're going to figure out what x is, we do order of operations backwards. So we subtract the 1 because it's the furthest away. And if you peel an onion, you have to peel it from the outside in. So we start with the backwards operations and work our way forward. Okay, you want to see another one? 30x squared plus 37x plus 10. Let's do one more together, and then I'll give you guys one to solve. Write it in your notebook. It'll be good for you to follow along. So I create a 300x squared, and then I look for the factors of 38 that add to be 37. What do I know about the signs? 300, sorry, that adds to be 37. This number tells me they're the same, and this number tells me they're both positive. So 1 and 300 obviously doesn't work. 2 and 150, 3 and 100, 4 and 75, 5 and, let's see, that would be 20, 40, 60, 6, so it would be 6 and 50, 7 isn't going to work, 8 isn't going to work, 9, what's 300 divided by 9? Does that one work? Brooklyn's got a calculator. 300 divided by 9. No? Okay, hold on. Let me make sure I did this right. So 10, 30, 25, and 12 is 30. Okay. 9, 10, and 30. That doesn't work. 12. Does 12 work? I doubt it. 25 and... Oh, 12 and 25? Hey, there we go. We got it. So it's 12x and 25x. So I bring down the start and the end. 30x squared. Does it matter where I put the 12 and the 25? No, but it will change the order of your factors. So if you put the 12 first and I put the 25 first, then when we factor it at the end, our factors will be flipped, but they'll still be the same. So plus 12x plus 25x plus 10. And that's the hard part. If you can get here, the rest of it's easy. So now I factor by grouping. What does the first group share? 3 would work. 6 would work. And you need to take out the biggest possible number. So 6x, leaving 5x plus 2. What does the second group share? A 5. So plus 5. And if I pull out a 5, what's left? And that's what we wanted. We wanted 5x plus 2. So one of the factors is 5x plus 2. If I turn that into a root, what do I get? Subtract the 2, divide the 5. So one of them is negative 2/5, and the other one is created with 6x plus 5. So it's going to be negative 5/6. And those are my answers. Okay, let's try another one. Nope. Quick, somebody tell me 56 times 4. Wait, 224. Is that right? Yeah. I did 4 times 50 is 200, and 4 times 6 is 24. So if I combine those, I get 224x squared. So I'll give you a... Okay. So now I'm in a group. And I get... times... All right. I've got a problem. Nothing factored out. Yes, you can always pull out a 1 without changing it. Now, if you ordered your 32 and your 7 in a different way, then you wouldn't run into this problem. Well, actually, you probably still would, but it would just be the opposite problem. So that's going to be a 1. So one of my roots is going to be 4/7, and one of my roots is going to be negative 1/8. Because you have to subtract that 1 and then divide the 8. Does that make sense? Yeah, you set it equal to 0, subtract the 1, divide the 8, and you'd get it. Okay. All right, last one. 6x squared minus 29x plus 35. So 6 and 35 is going to be 180, 210. Who's got a calculator? 210? So 210x squared. What do I know about the signs? They're both going to be negative. So I'm going to have 6x squared and a 35, and I need to find the factors of 210 that end up being 29. So 1 obviously isn't going to work. 2 and 105, that won't work. 3 and something big, not going to work. 4 doesn't work. 5 and 42, that one's not it. 6 and 35, that's it. Okay, and I know they're both negative, so it's minus 6x minus 35x. Oh, you're right. I was doing different signs. Thank you. That's not right. Okay. So 7, 7 and 30. That doesn't work. 8. Does 8 work? Nope. So 9. 9 doesn't work. 10 and 21. 11. 12 doesn't work. 13. 14. I hope that's it. 14 and 15. There we go. Okay, let's do it the correct way. Minus 14x minus 15x plus 35. Okay, this one's a little bit tricky. Whenever your signs are both negative, you're going to run into this little trick. So I'm going to pull out a 2x, which leaves me with 3x minus 7. What do I want to pull out of the second set? But they don't both have a negative. Only one of them's negative. But if I pull out a negative, it'll change both of them, not just one of them. How do I know I need to pull out a negative? Right, when I'm finished, I'm going to have x. I want to end up with 3x minus 7. This parenthesis and that parenthesis have to match. Well, if I pull out a 5, do they match? Almost. The numbers are right, but the signs are wrong. So you need to pull out a negative 5, and that will change both of those to match the first set of parentheses. So my roots are going to be 7/3 and 5/2. So your assignment today is just to finish, this is the wrong worksheet, to finish the rest of that worksheet. Okay? And the answers are on there to help you make sure that you show your work.